Now our second proof by mathematical induction is this statement. 1 plus x squared plus dot 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 all the way up to x to the nth power is equal to 1 minus x to the n plus 1 over 1 minus x. If x is not equal to 1, obviously x can't be equal to 1. And we need to prove that that's true for all values of n. So we'll use the proof by induction technique. And I think to save myself a little bit of writing, I'm going to circle this and call that proposition sub n. And then it'll save me from rewriting it again a little bit later. All right, well, let's do our base case, which is n equals 1. So if n is equal to 1, this left-hand side is 1 plus x to the 1, just 1 plus x. We need to show, and I'll maybe put a question mark there because we don't know yet, that that's equal to, when we replace n with a 1, we would get 1 minus x squared over 1 minus x. Doesn't look exactly the same, but notice that that's a difference of two perfect squares. 1 plus x times 1 minus x, if you factor that difference of two perfect squares. Over 1 minus x, I'll put it in parentheses because I'm going to cancel it out. And we get 1 plus x. That's exactly what we wanted. So there we go. Our base case worked. Now let's, for our inductive hypothesis, let's suppose that pk is true. So that simply means that I replaced the n with the k. So it means that 1 plus x squared all the way up to x to the k is equal to 1 minus x to the k plus 1 over 1 minus x. And we're going to do that to prove pk plus 1. So that's kind of a story telling the reader what we're going to do. Suppose that's true in order to prove that that's true. Okay, pk plus 1, I'm going to write it down in brackets here just so we know what we want to prove. pk plus 1 is the statement 1 plus x squared plus up to x to the k plus x to the k plus 1. We have to go one term farther. We have to prove it's equal to 1 minus, I'm replacing n with a k plus 1. So that would be 1 minus x to the k plus 2 over 1 minus x. And obviously x can't be equal to 1. So this is what we have to prove. So let's say that, but we know that this left-hand side, 1 plus x squared plus dot 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 plus x to the k plus x to the k plus 1 is equal to, and now remember, we're trying to prove this. We can't just write that here. We need to use some algebra to prove that. But using the inductive hypothesis, we know what this is. That's equal to this, only with a k. So it'd be 1 minus x to the k plus 1 over 1 minus x. And then we just have to add this term to it, plus x to the k plus 1. We're going to do a little bit of algebra, and I know what we're going to end up with, unless I make an algebra mistake. We're going to end up with this, and that would complete the proof. So let's get a common denominator 1 minus x to the k plus 1 over 1 minus x. This would be plus x to the k plus 1 times 1 minus x over 1 minus x. So now we have a common denominator. I'll write it as one fraction, and I'm going to do something else. I'm going to distribute this through also in the next step. So I know the bottom is going to be 1 minus x. I've got 1 minus x to the k plus 1. This times 1 gives me plus x to the k plus 1. This times the negative x gives me minus x to the k plus 2. And I think we're just about where we need to be. These two terms are equal to 0, so we get exactly what we're looking for. And that completes the proof. Simple.